Okay. Hi, everyone. My name is Yasuhiro Inami, and I come from Japan. And I'm very excited to speak in this iOS conference in Singapore. And thanks to Serve and everybody volunteering for organizing this event. And today I will talk about a fun topic called reactive state machine. And throughout this talk, I will talk a little bit, a lot about reactive programming. And how many of people here are known as about reactive programming? Can you raise a hand? Oh, great. So like more than half people maybe know about reactive programming. So, and if you're not familiar, maybe this topic can be a bit difficult, but just calm down, and I hope everyone will enjoy it. By the way, I'm working at a company called Line, and it's a messenger platform based in Tokyo. And there are also like Korea, Taiwan, and many other countries, branches. And we developed many variety of apps, such as camera, news app, games, and so on. And if you're interested, please contact me at any time. So let's get started. So what is reactive programming? To illustrate it in just one diagram, it will be something like this. The horizontal line is the time flowing to the right, and the circle represents the value that can be sent multiple times. And this flow will be terminated either by error, the x, or the vertical line is a completion. In short, reactive programming is a way of handling streams of values over time. Here are some famous Swift FRP libraries available. And FRP stands for Functional Reactive Programming. And among all, RX Swift is probably the most famous one recently. And also we have a Reactive Cocoa since Objective-C. And besides those two, there are many other libraries, such as SwiftBond, ReactiveKit, Interstellar, ReactKit, and so on. In any of these libraries, their goals are basically the same, to construct the data flow in an easy way. So data flow is just like the river, and the water runs through it. As we all know, that water runs from the mountain to the ground and to the ocean, and it goes back to the mountain again. It just keeps flowing. But sometimes the flow can be made artificially, like this picture. So did you notice the barrel on his head? And I think you can imagine what will happen next. So like this, splash. The water will flow. And that's the law of nature. And by the way, we can also pour the water back to the bucket and repeat the same thing again, if we want. So and in reactive programming term, we can say like this. The bucket, water bucket, is a state, temporal state, and that is observable. And by pulling the rope, we can observe it. And this observer gets wet. This kind of water control is our example of state management. And it's all about getting and setting the state, setting the variables. Now, let's take a look at how we can handle these states using MVVM pattern. MVVM stands for Model View View Model. Let's take a look at how to set the state first. So here we have a view model class with three properties: the raw value and the variable, which is RX Swift's variable, and the mutable property. This is a Reactive Cocoa's mutable property. And to set the state, for example, raw value, we can just call viewModel.RawValue equal something, and we can just set a state, easy. But unfortunately, this is not a reactive way, meaning it only updates the value once. What we rather want is to keep updating the value as the state changes. And we can do so by using data binding mechanism. And to do so, we can use like event emitter structure to keep observing changes, like this lines, my super event emitter.on or something like that. And in FRP, we can even use observable or signal to do the same thing instead. For example, in RX Swift, this one is called observable.bindTo, and you just bind to the variable. Easy. And in Reactive Cocoa, we can use the custom operator to do the same thing. So for setting the state, it's relatively easy for any cases. But how about if we want to get a state? One way is to just call viewModel.lowValue and extract the value. And it's easy, but again, this is still a pro model. Means we can't push the value to start making a data flow. There's a workaround though. We can use KVO for that. But to do so, we need a power of Objective-C with dynamic keywords in it. And it's not, as we are Swift developers maybe, I think it's not really a recommended way nowadays, I think. So fortunately, by using FRP, we can do it better. In Rx Swift, you can use variable, and it can be turned into observable, and like call doOn function, and start observing the new states. And in Reactive Cocoa, we can do mostly the similar thing. So to summarize these FRP concepts, we can say that observable or signal is really the same as event emitter. And variable or mutable property owns the state, current state, as well as it's transformable to the event emitter. And by using these FRP types, and we apply the MVVM pattern using data binding, we can eventually handle the states very easily. And it means we can create our apps very easily. So, yay! FRP plus MVVM will solve all our problems. Happy end. But wait a minute. Is that really true? We should take a look at more edge case here. And let's see. Here comes a new challenger. A wild Pokemon appears. His name is called Weedle, but in this talk, please rename it to a view model. So Weedle, view model sounds similar, right? And wait a minute. Here comes the next view model. Another wild view model appeared. Let's call this view model 2. And then, oh, here's another view model. So the view model number increases like view model 3, view model 4, view model 5, until it reaches to as many as the number of existing UI views. Let's say we have 1,000 views, view models here. And please imagine what will happen if these view models start to link together. For example, we might have to write the code like this one. Let's say the first variable is mapped and binded to the second variable. And second variable is asynchronously flat mapped and binded to the third variable, and so on. If we keep doing this, these 1,000 view models will eventually create a very, very complex data flow like this one. Suppose if your teammate writes a code like this and sends a pull request and asks you for a code review, how will you react? Probably you will try read the code, but you will soon get headache and you realize that everything was actually LGTM. So here's the consequence. 1,000 view models creates a spectacular data flow that no one can understand. Countless states are linked together, but all scattered and messed up. But somehow our app is running. It's a miracle. What I want to say here is that even when we are using FRP and MVVM together, it is not that easy to control the application's whole states, because creating data flows and managing states are completely different concepts. What do I mean by this? Let's take a look at this more deeply. So, for instance, we have a data flow like the first line. The variable is it is almost bind to, and it's binded to the UI. So when the variable changes, the UI gets updated automatically. But in here, we have a serious problem, and that is we have a risk that we might set the wrong value to the variable manually, like this poop things. Normally, we should never write this kind of code, but we all make mistakes, and especially when we are working with a team. And in most cases, the problem can be discovered only at runtime. So that means the red variable, actually it has an internal value in it. It's too easy to get mutated. And it's not so different from var row value. We don't like var, right? So, okay. And second problem here is we have the same flow as before. And now it's still too easy to get connected with other data flows, like this one, to the variable manually. So previous example was only one poop was flowing, but this time it's like whole toilet is like piped in. And multiple or endless poops are going to flow. And this is really a nightmare. And even worse, we are facing with the another problem. And that is, we actually, when you call bind to, we create an instance called disposable. And this is actually a part of state. So in other words, whenever we make a data flow using FRP, we are actually creating a new state. Even shorter, data flow is a state. So far, so bad. Oh my God. We tried to adopt FRP and MVVM to manage states, but paradoxically, the number of states were actually increasing. So we have to ask ourselves, who are you going to vote? No, I mean, joking. Are we really managing the states in the right way? And probably not. So until here, I talked so far, we have seen the data flow that is rapidly changing its shape. And we have also seen countless predictable states floating around. And it's just chaos. We have to improve this situation as soon as possible. To do that, I think we need a new way of thinking. First, we should fix the transient data flow, stabilize it. And second, we need to reduce the number of states to make it more visible and understandable. Okay, that sounds great, but how should we do? And where should we start from? Fortunately, we already have a good practice, in the web development world. And I would like to introduce it. And it's actually React.js. From now on, I'll talk about JavaScript world. Sorry, this is iOS conference, but a bit of JavaScript now. So let me talk about what is React.js. Basically, it is very similar to UIKit, UI view controller and UI view. But the biggest difference is we treat them as immutable structures. Right now, UI view has a lot of mutable var properties, but we think of them as constant let properties instead, and never try to mutate it. And it must be stateless. And next, React.js has a class called component. And this handles the state instead of raw DOMs. It uses a technique called virtual DOMs. And what this does is when the state changes, it makes incremental update takes place. And only a minimum amount of view gets re-rendered. This rendering flow works from parent component to the child component. And this is the reactiveness of React.js. But it doesn't mean the same as reactive programming, so just be careful. And this is a diagram of React.js component hierarchy. As we can see, the components are constructing trees like UI views, each component having states. But when using React.js, it is a good idea to put all the states to the topmost node, so that when it gets updated, the children will get updated automatically. And here's what happens if child component receives the user event or action. The event flow will be like this. First, the bottommost component receives the event, and it bubbles up and propagates to its parent component. And it keeps doing the same until it reaches to the topmost component. And then topmost component calls a function called setState that eventually updates its internal state, and incremental update takes place to every child components. But in this process, we find a bit of a difficulty. That is, we have to delegate the event from bottom to top, one by one. And this is really cumbersome. So we can say that React.js is good at performing top-down data flow, but it has difficulty in bottom-up data flow. And how can we improve this problem? Actually, JavaScript developers don't use React.js as a standalone framework. And they also use the companion library, and that's called Redux. If we use Redux, this diagram, previous diagram, will be improved like this diagram. Let me explain how it works. First, we have a state container on the right called store, and we treat this as a singleton to manage the whole application state. By doing so, states are completely moved away from React.js, so these React.js components can be more testable. And also, components in any level can now send the action to the store. So from bottom, child to parent flow will be dramatically improved. Once the action is sent to the store, it will pass middleware, then reducer. And it will be converted to a new state, and it also generates some side effects, the I/O. And lastly, the store's listener, the React.js in this case, will receive the newest state, and it does incremental updates. And this is the outline I just talked. By combining React.js and Redux, the data flow will be fixed now, and the number of scattered states are now gathered into a singleton container. Also, the idea is very familiar and fits to the functional and immutable world. So I think this is really a breakthrough architecture. So React plus React Redux, everything will be perfect. But actually, there's a problem in Redux. The biggest problem is the position of middleware. As we just saw the Redux diagram, the middleware, this one, middleware and reducers are both lined up like this. And their roles are different. And therefore, they are completely separated. But in practical code, we often want them coupled together. That means, instead of applying reducer only after middleware, we want to apply reducer and middleware at the same time. And if you dig into this more carefully, Redux basically has a difficulty in asynchronous tasks. There's a workaround, such as action creator or using middleware. And for using middleware, there are some implementations like Redux Thunk, Redux Promise, ES6 generator, or observable, but they all have problems. And that is, we can't predict the data flow if the multiple middlewares start to work asynchronously and start chain reaction. And in my personal opinion, FRP is much simpler and most composable way of handling asynchronous tasks than middleware. So I think it's time to think for a better architecture. Let's think about a better Redux. To do so, let's first take a look at the types in Redux. In here, please only pay attention to the reducer type. And this is, you take two arguments that are given, as an argument, and that is current state and input action from outside. And it creates a new state. And actually, this, if you have ever learned computer science before, actually, this is just a state machine. Or we also call it automaton. To talk about state machine, the topic is too deep to discuss, so I will only pick one. And in short, Redux is almost as same as Mealy machine. Then, what is Mealy machine? Mealy machine is a finite state machine or a finite transducer that takes current state and input as an argument, and it creates a new state as well as making output together. The difference is here is, unlike Redux, it also creates an output at the same time. And the 6 tuple Greek symbols I just showed a little bit means like this. The sigma stands for the set of input, omega stands for set of outputs, S is the set of state, and S0 is one of the state, initial state, and delta is a state transition function. This means you receive current state and input, and it generates a new state. And the lambda is the output function that takes current state and input, and it generates an output. And if these 6 symbols are all set, we can call it Mealy machine. And if we compare these 6 types with Redux, as we can see, most of them are just equivalent. So Redux actually has the same mechanism as Mealy machine, which existed since 1955. But this is now 2016 now, right? So we don't want to reinvent the wheel again. Since we are heavily using FRP nowadays, it is a good idea to improve Redux in more FRP way. So, do you know this one? Let's combine these two. I have Redux, I have FRP, and you just put together. Okay, I like it because everybody knows it now. Okay, so here are some improvements I made. First, we combine reducer and middleware into a single function, like the top one, and to make the function as a simple and become more clean to read. Also, state transition might fail sometimes, so we actually return the optional here. So we can avoid the unnecessary method dispatches. Next, we use FRP for asynchrony, and for this talk, I will use Reactive Cocoa. And lastly, for the output of Mealy machine, we will use the signal producer to express the side effects. And this is actually the open source I made for this talk, Reactive Automaton, which is for Reactive Cocoa users. And I also made RX Swift version too, called RX Automaton. Please check this out. If you know both, please check both. And these are the lists that translates Redux to the Reactive Automaton. And for now, I just leave the explanation because maybe I don't have time. So, and now let's take a look at how to use this Reactive Automaton. And this is a state transition diagram illustrating the simple logging flow. We have 4 states here. The left one is logged out, not logged in yet. And we transit to logging in state and logged in state and logging out state. And then we have corresponding inputs. And here we have an interesting input called false logout. And that basically transits from logging in or logged in to the logging out state. Sorry, it's a bit hard to speak, but yeah, you have 2 extra arrows in it. And this is actually used for for example, like server side returns a 403 error from API request, and they want to force log out to the client side without user decision. And state transition function will be like this one. I used switch cases all around. And if you take a look at first case, this means you are in a current state is a logged out state, and you receive the log in input. That means you should transit to the logging in state. And also, you can add extra side effects like this one, the logging OK producer. And these side effects basically do some I/O, like initializing the database, set up the UI, and so on. And if you're not interested in setting up the side effect, I mean, setting the I/O, you just set empty instead. Or if the transition doesn't even exist, you can just set nil like this. So far, it seems good, but this code seems a bit difficult to read, right? So here's a technique. I used the Swift's custom operator to support like markdown table-like syntax. So this seems more easy to read, right? And then we use the mapping function, mapping instance that I just talked to initialize the automaton like this one. And we can now observe its transition success or failure by checking its reprise signal. And now let's test this code. First, we are in a logged-in state, and we send the logout message input. And the state will transit to logging out state. And if we just leave it for a while, it will automatically perform the I/O inside, and like logouts, clean up the disk, and so on. And after that, it will automatically transit to logged out state. So like the third line. And then now you will send the logging input, and you will transit to logging in state. And if you leave it for a while, the side effect takes place, and you will be logged in state. But before that, let's send false logout here. The state will transit to logging out state, and sometimes you can cancel out the previous side effects. And now the new side effect called false logout OK producer will be performed instead, and it will transit back to the logged out state, meaning the logging in is failed in this case. So to just show the demo, let me explain a little bit. So here's a transition diagram. And we have 3 inputs here. And I just talked 5 inputs, but 2 inputs are used for internal purpose. So we have 3 input buttons. And let's see. When you press login, the state will transit to logging in. And you do nothing. You just transit, automatically redirects to logged in state. And if you press logout, it will be like this. Only pressing one button, and then it transits twice, because of side effect. And if you notice, you press the wrong button, the transition doesn't occur because it's not declared. And you see the false logout. You can false logout like this. And you can just prevent the mistapping, because the state invalid transition. So here's a brief summary of reactive automaton. In the demo, we just saw this very simple login flow, but we can also use it if we want for the big whole application state management, like React.js and Redux. And in addition, this architecture is actually quite similar, very similar to the Elm language. What is Elm language? And it's actually Auto.js, and it has a syntax very similar to Haskell. And Elm has a type called program, and it has also an effect manager as a core feature. And this eventually responds means to the automaton type. And also, Elm's model is equivalent to state, and message is equivalent to the input, and output function can be written like state transition function and output function, and which are just I talked about so far. So throughout this JavaScript talk, I talked about React.js, and which has a companion library called Redux, and it's basically same as Mealy machine. And if you combine with FRP, you can now get like Elm-like architecture. Nowadays, many iOS developers use FRP and MVVM together probably, but maybe there might be a one day that it can become obsolete one day and replaced to a new architecture as these web front-end frameworks suggest. And that is, there might be a day that we transit from model view model to automaton-based model view automaton. And lastly, this is a recap for my whole talk. So far, we have seen FRP and MVVM, but they basically have difficulties in state management because data flows are states, and MVVM is not a perfect solution yet. And I think we should learn more from new programming paradigms such as React.js and Redux. In the other half, I talked about reactive state machine. And this is basically the combination of FRP and Redux. And as a side note, I also recommend to check Elm language as well. It's very related to this topic, and it's even more advanced maybe. And it's a very interesting language. So this is it for my talk. Thank you very much for listening. Now if you have any questions. And also please check out my libraries too.
Thank you very much, Yasuhiro. Unfortunately, we don't have time for questions.
Sorry. No problem.
So we'll break for lunch, and if you have any questions, just
please ping me at lunchtime.
Exactly. So you can approach him during lunchtime and